Daigneau. Hey, Gil, how are you?
Good, Steve. Thank you.
So listen, tell us what you're going to tell us. You've got a chart that you want to share. Well, what's it about and why is it important?
Well, I really want to talk about carbon because carbon's really kind of the focal point of a lot of attention these days. Carbon in the atmosphere. And it's suggested that carbon in the atmosphere is what traps heat from sunlight and contributes to global warming and climate change. So it's a real important issue. And I want to kind of go through that and explain the dynamics and the percentages of carbon that are in methane and the percentage that's in carbon dioxide. And I have a real good flow chart that we can go into to show that.
All right, very good. So let's go and look at that chart.
We're going to take a real close look at carbon in the atmosphere and also carbon sequestration, carbon that is stored in the soil. The Environmental Protection Agency says that 12% of the carbon in the atmosphere is from methane. However, 80% of the carbon in the atmosphere is from carbon dioxide. Methane typically breaks down in the atmosphere in 10 to 12 years. However, carbon dioxide has a very strong double bond and it takes 300 to 1,000 years to break down in the atmosphere. You can look that up on Google. But there's an interesting dynamic called photosynthesis in sunlight. So all grass and plant material through the process of photosynthesis with the energy from sunlight absorbs carbon dioxide from the atmosphere, breaks it down, and releases oxygen, which we breathe. You probably agree that's extremely important. But if we look at that dynamic of photosynthesis, oxygen release, carbon absorbed, the carbon that's absorbed goes into the soil profile under the ground, and it really is important for the soil microbes and fungi. So carbon is naturally sequestered, stored in the soil. A portion of that carbon supports below ground life of its inhabitants like soil microbes and soil fungi. These in turn release a little bit of methane back into the atmosphere. The small amount of methane that's released back into the atmosphere from soil inhabitants and activity breaks into hydrogen gas and free carbon that bonds with two oxygen molecules to once again become carbon dioxide, some of which goes back through the photosynthesis lifestyle. Well, a good question to ask is, how does that pertain to agriculture? Agriculture these days is being victimized, is really contributing to global warming. And in particular, within that, the cattle industry is being demonized as causing climate change. Well, according to the EPA, all of agriculture is 11.9% of the carbon in the atmosphere. And within that 11.9%, 1.9% is from the cattle industry, according to the University of California at Davis. So how does that relate to the cattle industry and agriculture? Well, that carbon that cattle are using is the same carbon that 60 million buffalo used until we wiped them out in about 1880. But there's a unique thing that happens with grass and cattle. You've heard a lot about rotational grazing, regenerative agriculture. Well, grass grows and it has a thing called lignin, and it's a structural carbohydrate that's not digestible. So it's just like a building. The taller you make a building, the more steel structure you need to support the height. Grass is the same way. Think about how you mow your yard. When you mow your yard and the grass is young, it starts growing real fast, but the taller it gets, it slows down. Well, the faster grass grows, the higher metabolism it has, and subsequently the more oxygen it releases and the more carbon dioxide it sequesters. Actually, an acre of grass produces more oxygen than an acre of rainforest. You can also look that up. So the way rotational grazing works is that cattle graze it almost like you're mowing your yard. They'll graze a pasture and cut the grass short. The grass starts growing back, and as it's growing back, you move the cattle to another pasture and they start grazing that. That way you always keep your grass at an optimum level. And as far as manure is concerned, really that's a concentration of plant material that the cows are pooping out. And that's absorbed into the ground, and it helps feed those inhabitants in the soil in what's called the root zone underneath the plants. And as you can imagine, other than the energy from sunlight and photosynthesis, all of the nutrition for a plant comes from the ground through the roots. So that root zone is real important to have it healthy. And regretfully, a lot of the synthetic fertilizers that we use these days, it's said that they sterilize the soil. They don't contribute to the growth of the microbes and the soil fungi. So manure is a natural fertilizer that's a really good one. Maybe that will explain some of the life cycle of carbon for you. Thank you.